In this video, I'm going over lesson 1.2, which is on distance and midpoint between 2 points on the coordinate grid. But before we get started, there are the two review questions reviewing Pythagorean theorem. So for those of you who don't remember Pythagorean theorem was finding the distance between 2 points, but creating that right triangle where we have the two legs, A and B, that create that right angle. And then you have C, which is the hypotenuse, which is always opposite. And then here, it was a squared plus b squared is equal to c squared. So there's that reminder for those who didn't remember Pythagorean theorem. So go ahead and pause the video and at least then try at least the triangle here and then see what you get. And here we go. So notice how you are given the two legs. So you were given A and B. You are looking for C, which is the hypotenuse, which is opposite from the right. So you have 8 squared plus 3 squared is equal to C squared. So this is what you were supposed to solve here, which you have 64 plus 9 is equal to C squared. So I've got 73. But then always here, it's C squared. So now take the square root. And then we'll turn this into a decimal. So C is approximately 8.5 feet. So now notice here, we are again finding the distance between the 2 points because we're looking for the length of PQ. Well, you can't just really count, however, almost treat it as if like a slope where I can create a distance as if it's a right triangle. So now if you create the right triangle, well, what do you notice? Well, this side of my right triangle is 3. This side of my right triangle is 8 because I can count the units. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. And we are looking for the distance or the length of PQ. So like I'll put L for length. So really in the end, you should now notice that these two problems are the exact same. You are still using Pythagorean theorem. So in this case, again, 8 squared plus 3 squared is equal to L squared because we're looking for the length, which is C. And then same thing, you end up with approximately 8.5. So notice you can use still Pythagorean theorem on the coordinate grid. However, we're going to also talk about not just Pythagorean theorem, that first method, but also eventually getting to the distance formula. So here we'll just first focus on this example, the Pythagorean theorem. So again, here we're looking for the distance between the 2 points, how far Tiana has to walk from home to school. So that distance here from home to school. So for now, let's still go ahead and identify the point. So here, home is at 2, 2, and school is at 5, 9. So let's go ahead. We're looking for the distance, right, between these 2 points. I'll put D there. But again, we can use Pythagorean theorem by connecting those 2 points like a slope, right? We're creating that right triangle and then counting. So 1, 2, 3. And then our distance here is 7. So here we've got 7 squared plus 3 squared is equal to D squared or C squared or X squared. I'm just using D for distance for now. And then we can just go through and solve. 49 plus 9 is equal to D squared, which here now you have 58. And then of course, last step here, take the square root to solve for D. And the distance is approximately 7.6 units. So again, like I said, we're going to go back to the distance formula to discuss that. But keep in mind, if you notice any patterns in regards to finding that distance besides creating the triangle and counting. So same thing here, but now I gave you the point. So let's go ahead and plot the point. So -1, 6. So -1, 6. Let's label that A. So here we'll label A. And so point B is at 5, -3. So again, we're finding the distance, right, between these 2 points. So again, creating that right triangle. Let's go ahead and get those distances of our right triangle. So again, we have -1, 6 here, and we have 5, -3. So here my vertical is 9, and my horizontal is 6. So now here I've got 9 squared plus 6 squared is equal to d squared. I've got 81 plus 36, which gives you 117, but then of course take the square root. So d, the distance, is approximately 10.8. Now, start looking to see if you notice a pattern instead of drawing the right triangle and doing the counting. What do you notice about the vertical distance and considering the coordinates? What do you notice about the vertical? What do you notice about the horizontal? Notice a pattern here when solving. What do you notice about the horizontal? What do you notice about the vertical? Well, I notice you get the horizontal here, which is parallel with that x-axis, right? I have the distance between the two x's, 5 minus 2, which gave me my x, which is 3. So notice your vertical parallel to your y is the distance between the two y's, 9 minus 2. So now keep in mind, so if that is here, if you think about it, that is the distance formula. It's taking those values and substituting here. So I've got the distance formula, which is we're finding the distance, right, between the two x's. Well, there's two x's, so I can't just put x and x, right? I'll put like a x sub 2, x minus sub 1. Same thing here. We're finding the distance between the two y's. Now go back to Pythagorean theorem. What did we then always do with those two values? Well, we always squared them, right? We always found the distance, but we didn't just add them together. We also squared them. And then what did we always do once we squared them and added them together? Like our answer wasn't just 58. What did we then do? Take the square root. That is distance formula. It's finding the distance between the two coordinates and squaring, finding the sum, taking that square root. It is all the same as Pythagorean theorem, and this is the distance formula. So again, notice if you wanted to use distance formula, so this is equal to d, we're taking the square root of finding the distance between the two x's, which were 5 and 2 squared, plus the difference between the two y's, 9 minus 2 squared, which is equal to d. Then I have the square root of 3 squared plus 7 squared, which here again, there you go, square root of 58 because of 9 plus 49, and there you still get square root of 58, which is approximately 7.6. So here, let's do the same thing and practice distance formula. So again, we're taking the square root of, right? Finding the distance between the two x's. So the two x's are 5 and -1. So 5 minus -1 squared. Then we always added to that, right? The distance between the two y's, which are 6 and -3. 6 minus -3 squared. Notice how really in this case the order does not matter because in the end we are squaring. So you're still going to get the same value, which is equal to d. So now here I've got 6 squared plus 9 squared. So now notice we're right back where we were with Pythagorean theorem, because when you square and add together, you still get the square root of 117. So now just to show you guys, you would still get that same answer, right? Here, if I've got my first point here, so let's say this is x sub 1, y sub 1, and x sub 2, y sub 2. So here, second point minus the first point. So again, 5 minus -1 plus then -3 minus 6 squared, right? Because y sub 2 minus y sub 1. Yes, you end up with -9 here now, right? Because you have 6 squared, but now you have -9 squared. But remember still, even though that this is a negative, two negatives still make a positive. So that's why here that order doesn't matter, because with squaring, and you will still get that distance of 10.8. So go ahead and pause the video, calculate the distance between these 2 points, and let's see what you get. And here we go. Now you could have gone either way, Pythagorean theorem or distance formula. I'll show you guys again how you could kind of do a mixture of both, because it's very difficult to count, right? However, I can find the distance between my two x's if I'm going from 8 to 53. That means this length is 45, right? 53 minus 8. So that distance is 45. So then here, the distance for my y's between 12 and 22 is 10 units. So now I can set up and solve for d, my distance. 45 squared plus 10 squared is equal to d squared. And then going through and solving. So here you should have gotten 2025 plus 100 is equal to d squared. You've got 2,125 is equal to d squared, and then of course, take the square root. So the distance between the 2 points, the length of PQ, is approximately 46.1 units. So now getting into the midpoint. What is the point that's in the middle of, let's say, the line segment? So midpoint formula is, we are now going to take, actually, you know what? How about this? Before I give you the formula, let's go to example 2. And let's identify, because you could identify visually, what is the midpoint of AB and BC. So then we'll identify possibly what that midpoint formula is. So let's identify the midpoint of AB. Well, A is here at 0, 8, and B is at 8, 0. So if I notice visually, my midpoint in the middle here is right here at 4, 4. So keep in mind, that is the midpoint. So now notice here, the midpoint of BC. So B is at 8, 0. C is at 0, -8. So the midpoint here is 4, -4. So notice now a trend here, because we got to figure out, right, what is my x coordinate and what is my y coordinate, right? So here, my x coordinate, well, I have 0 and 8. So I have 0 and 8, and my y coordinate, I have 8 and 0. For again, my x coordinate, I have 8 and 0. Oops, sorry about that. I have 8 and 0. But for my y coordinate now, we have 0 and -8. We ended up with the midpoint of 4, 4. We ended up with the midpoint of 4, -4. So what do you notice? What do you think we're going to need to do to calculate the midpoint? We're going to add the two coordinates. So in this case, because 0 plus 8 is 8, and then find the halfway middle, divide by 2. 8 divided by 2 is 4. 8 divided by 2 is 4. And then when you add, you get negative 8 divided by 2, which is negative 4. So let's go back now and fill that in. So we're going to take and add the two x's, divide by 2. We're going to take our coordinates, our two y values, add them together, divide by 2. So that is the midpoint formula. So here we can see it visually, but let's go ahead and practice using the formula here. So again, we have the point 0, negative 8, and B here is at negative 8, 0. So again, we have our x coordinate, we have our y coordinate. Our x coordinates are 0 and negative 8. Our x coordinates are, y coordinates are negative 8 and 0. So again, we're going to add the two coordinates, divide by 2. So now here we have the midpoint of negative 4, negative 4, which matches visually here, negative 4, negative 4. So go ahead and set up the dA on your own. The last segment, set it up the formula, and then we'll check and make sure that it matches visually. And here we go. So again, you should have set it up, my two x coordinates, which are negative 8 plus 0, divide by 2. Take the two y's, which are 0 and 8, so 0 plus 8, divide by 2. So here you should get negative 4, 4, which let's see if it matches. Negative 4, 4 does match. So we do end up here with the midpoint. So go ahead and pause the video and do this you try on your own. And here we go. So here the situation is that Aaron and Heather live in the same neighborhood, but they want to meet at the midway point, right? So we don't want to know what the distance is. We want to know the midway point. So here we need to identify, well, Heather's house is at 4, 7, and Aaron's house is at negative 8, negative 3. So at what point on the coordinate grid are they going to meet? So again, you should have set it up. So here the midpoint, I need my x coordinates. So the two x's are negative 8 and 4. So negative 8 plus 4 divided by 2. The two y coordinates, negative 3 and 7. Negative 3 plus 7 divided by 2. So here you should have gotten negative 4 divided by 2 and 4 divided by 2, giving you the midpoint of negative 2, 2. So let's see, negative 2, 2. Sorry, my line was a little off. And that is the midpoint. So lastly here, without the visual, again, just practicing calculating our midpoint. So here we go. So again, making sure, right, that we are identifying our x coordinates. So here to find that middle. So here I've got 7 and negative 5. So 7 plus negative 5 divided by 2. So then the y coordinate is 2 plus negative 11. 2 plus negative 11 divided by 2. So here you end up with 2 divided by 2 and negative 9 over 2, which gives you the midpoint of 1 and negative 9 over 2, or negative 4.5. So go ahead and pause the video and try the you try now on your own. And here we go. So you should have set it up as getting the x coordinate. You have the x coordinates of negative 6 plus negative 15, then divide by 2. And here you have the y coordinates of 4 and 12, then divide by 2. You should have gotten negative 21 over 2, or negative 10.5, negative 10.5. 8 is your midpoint.